Every morning it rises, every evening it sets. For all of human history, the sun has been our constant companion. The giver of light, the source of warmth, the heartbeat of all life on Earth. But how much do we really know? In 2026, we know more than ever before. We've sent probes to touch its atmosphere. We've mapped its interior using sound waves. We've discovered that its outer boundary looks like an angry pufferfish. And we've learned that one day, it will consume our world. This is the complete story of the sun, our star, our destiny. 4.6 billion years old, 1.3 million times larger than Earth. 15 million degrees at its core. Welcome to the heart of our solar system. Let's start with the raw numbers. The sun contains 99.8% of all the mass in our solar system. Its core temperature reaches 15 million degrees Celsius, hot enough to fuse hydrogen into helium, releasing energy that takes 1,000,000 years to fight its way to the surface. It is a nuclear explosion contained by gravity. By the time that energy reaches us, it's a gentle warmth on our skin. But make no mistake, the sun has been exploding for 4.6 billion years. The sun isn't just a distant ball of fire, it's the engine of everything, every meal you eat, every breath you take. But the sun is also temperamental. When it's angry, it hurls billions of tons of plasma toward us. These solar storms can disrupt GPS and even cause blackouts. As NASA says, we live in the atmosphere of the sun. In this documentary, we'll explore every facet of our star, from its hidden interior to its chaotic surface. From the 2026 discoveries that are rewriting textbooks to the ancient mysteries finally solved. From the solar cycle that affects our technology to the ultimate fate that awaits us billions of years from now. This is the complete story of the sun. Let's begin our journey inward. If we could slice the sun in half, we'd see three distinct regions. At the center lies the core, a sphere about 20% of the sun's radius. Here, hydrogen atoms are crushed together so violently that they fuse into helium, releasing enormous energy. Around the core is the radiative zone, where energy slowly bounces from atom to atom, taking up to 1,000,000 years to travel outward. And finally, the convection zone, where hot plasma rises like boiling water, cools at the surface, and sinks back down to be reheated. But how do we know what's inside the sun? We can't cut it open. Instead, we listen to it. In the 1960s, scientists discovered that the sun vibrates. It rings like a bell with millions of different oscillations. Just as earthquakes reveal Earth's interior, solar quakes reveal the sun's. It's like having an ultrasound of our star. The core is where the magic happens. Every second, 600 million tons of hydrogen are converted into 596 million tons of helium. The missing 4 million tons, converted directly into energy, gamma rays that begin their long journey to the surface. Every second, the sun releases the energy of 100 billion nuclear bombs, and we receive just a tiny fraction of that. On the sun's surface, we see this as granulation, a pattern of bright cells. Each granule is about the size of Texas. They're constantly shifting and reforming. This churning motion generates the sun's magnetic field, creating sunspots and flares. At the boundary lies the tachocline. Here, the sun's rotation changes abruptly, creating shear that twists magnetic field lines. This is the engine that drives the 11-year solar cycle. Without the tachocline, the sun would be magnetically dead. Understanding the interior is just the beginning. Next, we rise to the visible surface, the photosphere.